All right. So aside from you practicing a few more kinematics questions and handing in those practices for me in the form of an assignment, really we finished our review of kinematics. And I think most of you are feeling pretty confident you know what you're doing. So now we're going to just do a quick review of how we add vectors. Remember, there are both vectors and scalars. Scalars are the quantities that need just a size and a unit. They don't have a direction, whereas vectors have a size with a unit and a direction. And so back in grade 11, we talked about the fact that you should think of a vector as an arrow, okay? The length of the shaft of the arrow is how big the vector is, its magnitude, and the direction the arrow is pointing is its direction, okay? And remember that when you add vectors together, in order to do that, they always have to be head to tail. The head of the first one, which is this part, has to be touching the tail of the second one. And then it's called the head to tail or the tip to tail method. And what you get out, the resultant, is called the resulting vector, resultant. And it always goes from where the first one starts to where the last one ends. Okay, so when we're adding vectors, there are 4 cases, and those of you in Science 12-2 this semester, you've already heard these. Case number 1 is when they're in the same direction. And these are definitely borderline common sense. So if you have a force of 40 newtons going east and a force of 30 newtons going east, I've even drawn them head to tail for you. The resultant starts where the first one started, ends where the last one ended. It should be 70 newtons east. The rule then is add them and keep the direction. And same direction, or in other words, when the angle is 0 degrees. Case number 2 is when they're in, count well, 1, 1. When they're in opposite directions. So in this case, you would have 40 newtons going east, but then maybe someone's pushing against you this time, and the 30 newtons is going west. The resultant will still start where the first one started, and I drew them head to tail again, and ends where the last one ended. What's the rule? Subtract them, get 10 newtons, and keep the direction of the bigger one, which is east. What's the angle between them? 180 degrees. Okay, so that's case 2. Common sense, I think. Case 3 is when they're at right angles with each other. So when they're at right angles with each other, so in all of these ones we were like pushing on a box or something. So my 40 newtons is going east, but now my 30 newtons is perhaps going north. I can't add them up like this. I need to slide one of them over. So I can either slide my 30 newtons over here, and now they're head to tail, north. Or I could have slid, sorry, trying to get the cap off a different color. I could have slid my 40 newtons up here. It doesn't matter which one you do, because in the end, the resultant will still start where the first one started and ends where the last one ended. How do we find it? Pythagorean theorem. The angle between is 90 degrees. Square them, add them together, take the square root. You're going to get 50 newtons. But now what's going to be different is the angle. If you slid the 30 over, then it's going to be this theta. If you slid the 40 up, it's going to be this angle. Okay? It doesn't matter which way you did it, the directions will be different. So inverse tan of 30 over 50 is 36.87. So for the black one that I have here, the answer would be, 50 newtons, square bracket, going east first, 36.87, then you turned and went north. That's not a north. You turned and went north. Okay? Whereas if I had slid the 40 up, it would be 50 newtons, square bracket, going north first, and that angle is going to be 53.13, just the complement, and then east. These two answers are identical. It does not matter which one you do. Okay? So that's case 3. Case 4 is the fun one. Case 4 is any other angle. So other than the 0, the 180, and the 90. And there's really two ways to do it. Okay, so you're pushing with a force 40 newtons going east, and now your 30 newtons is going at some angle. Let's say it's 36.87 degrees. Okay, so one option would be, oh wait, and our resultant is here. Okay, so this is what we're trying to find. So one option would be to take this 36.87 and your 30 newtons that I didn't mark in, and find the x component and the y component. Okay, so the x component is the adjacent side, so it would be cos of 30 is equal to cos of 36.87 is equal to x over 30 newtons. So x will equal 30 newtons cos of 36.87. Cos of 36.87 is 0.8, so x should equal 24 newtons. Okay? And then y is the opposite side, so it should be sine of 36.87 is equal to y over 30 newtons. So y will equal 30 newtons times the sine of 36.87, 0.6, so y should equal 18 newtons. So this side is 18 newtons, this side is 24 newtons, and now once I've done that, it's like this hypotenuse isn't here anymore, and now I have a right angle triangle, where this side is 64 newtons, this side is 18 newtons. I can square them, add them together, and get my resultant and get my theta. So it goes back to case 3. Now, there's a second way, which we didn't really do when you go, oh, and so what we did here with the x and y, this is called finding the components. And that's what we're going to be starting out with forces in, okay? But the second way you could have done this is 40 newtons east, and this is your 30 newtons here, and your angle still here, and your resultant is like this. And so you could have used the sine law and the cosine law, because if this is 36.87 down here, then this must be 143.13. And so you have an angle between two sides, right? And so you should be able to use the sine law, the cosine law. In this case, it would be the cosine law first. Just to remind you, the sine law is sine A over A is equal to sine B over B is equal to sine C over C. Or if it's the side you're looking for, then write it as A over sine A is equal to B over sine B, and one of the A's and B's should be lowercase there probably. That's the sine law. Cosine law is C squared is equal to A squared plus B squared minus 2AB cos C. Pythagorean theorem, but it's not quite a right angle. You have to take something off because there's some missing. What are you taking off? The two sides you know. It's a cosine law, so put a cosine in there, C. How do you know which one to use? To use the sine law, you need an angle and its opposite side. So I have a side here, but I don't have this angle. I have a side here, I don't have this angle. I have an angle here, I don't have the side. I can't use the sine law. I have to, in this case, use the cosine law. But then once I get that side, then I could use the sine law to find the angle. Okay? So when you come back to class, we'll do some more with these. I just wanted to show you this as a quick review. Now go work on your kinematics questions. Okay?